Hi Kin learners, welcome back to my channel. I'm Miss Marine and I make educational content videos. In my previous video, we've learned about the angle properties of parallel lines cut by a transversal. And if you haven't watched that video yet, please click the description box below for the link of the video. So for today's lesson, I thought of sharing other properties, the properties of circles. In this video, I'm going to share 8 of the circle properties and their proofs, and also to apply these properties in finding unknown angles involving circles. At the end of the lesson, I'm going to give you a quiz, so pay attention really well. Come on, let's get started.
Circle property number 1, angle at center. This property states that an angle at the center of a circle is twice that of any angle at the circumference subtended by the same arc. Look at this illustration. Angle AOC is the angle at the center, and angle ABC is the angle at circumference, and these angles are subtended by the same arc AC. We measure angle ABC, we get 58 degrees, and angle AOC, we get 116 degrees. Notice that angle AOC is twice that of angle ABC. In short, we say that the angle at the center is twice the angle at the circumference. Now let's try to click and drag points A and C along the circumference of the circle, and observe that the values of angle AOC is always twice the values of angle ABC. The second property we're going to learn today is the angles in same segment. This property tells us that the angles at the circumference subtended by the same arc are equal. Or we could say the angles in the same segment of a circle are equal. Given the figure, the two angles ADB and angle ACB lie in the same segment formed by the chord AB. To prove this property, let's click and drag the points A and B along the circumference of the circle and observe that the values of the two angles are equal. Next property is the opposite angles of cyclic quadrilateral. It states that the opposite angles in a cyclic quadrilateral are supplementary. In this figure, we say angle ABC and angle ADC are supplementary, and angle BAD plus angle BCD equals 180 degrees. They are the two pairs of opposite angles in this cyclic quadrilateral. Again, to prove this property, let's click and drag the points A and D along the circumference of the circle and observe that the sum of the values of the opposite angles of the cyclic quadrilateral ABCD is 180 degrees. Another circle property is a straight line drawn from the center of a circle to bisect a chord which is not a diameter is perpendicular to the chord. Given this figure, a straight line OP from the center cuts the chord BC. Notice that the chord BC is divided into two segments, segment BP and segment PC. We measure the segments and we get 3 cm for both segments. So we say that a straight line from the center of a circle is the perpendicular bisector of the chord. Circle property number 5. Tangents drawn to a circle from the external point are equal. In this figure, straight lines BS and BR from point B touch the circle at points S and R respectively. We say that these lines are tangent to the circle. We measure segment BS and segment BR. We get equal length, which is 9.15 cm. Therefore, we can conclude that tangents drawn to a circle from external point are equal. Circle property number 6, angle in alternate segment. This property states that the angle between a tangent and a chord is equal to the angle in the alternate segment. Let's prove this property using this figure. Angle FBH is the angle between the tangent GH and the chord FB, and angle BEF is the angle in the alternate segment. We measure the angle FBH and angle BEF, we get 55 degrees for both angles. Therefore, we say that angle FBH is equal to angle BEF. Similarly, angle EBG is equal to angle EFB, applying this property. Circle property number 7. A tangent to a circle is perpendicular to the radius drawn to the point of contact. Given the figure, line segment AB is tangent to the circle and radius OR cuts the tangent at point R. We say that tangent AB is perpendicular to the radius OR at point R. Circle property number 8, angle at semicircle. The angle at the circumference in a semicircle is a right angle. In this figure, line AC is the diameter of the circle and angle ABC is the angle at the circumference subtended by the diameter. We say angle ABC is a right angle. Now let's find unknown angles applying the circle properties we have just learned today. In this example, we're going to find for the values of x, y, and z. Looking at the figure, we know that angle ERO is equal to angle x. They are angles in the same segment. Therefore, the value of x equals 22 degrees. To find angle y, we know that it is the exterior angle of triangle TCS. So, to find angle y, we just need to add its two interior opposite angles, 22 and 17. Angle y equals 39 degrees. To find z, we can apply the angle in semicircle property. So just subtract 39 and 22 from 90. Angle z equals 29 degrees. Now it's quiz time! Find the unknowns in the figure. You may pause the video if you need more time in solving. Solutions are posted at the end of the video. Come on, you can do it!